Assalamu alaikum, everybody. We are here to design a filter for to solve a problem for a specified industry that have interference signals for their transmission performance. Okay, so we try to make a filter that cancel the interfering signals as according to the criteria that appear here for the equation h of e to j omega modulus square, which is refer exactly to the magnitude less than 0.05, less than or equal 0.01, sorry. So for the frequencies that compromise from 0 to 0.2 pi frequency, okay? And the other limit is h, or this value h of e to j omega modulus x square greater than 0.95 and less than 1.00, and the other limit is omega in the interval of omega, which is compromise for 0.3 pi and 0.7 pi. Hence, as we initially guess that, also we have another limit that h of e to j omega modulus square, which is as I mentioned before, refer to the magnitude about less than 0.02 for the interval of frequency of 4.8 pi and up to pi. Hence, we can guess the type of the filter, which is as it appeared a passband filter, okay, and minimum stop band attenuation equal to 75.3. Here we are to sketch the tolerance diagram and make the designing for the filter. So for the first step is how to draw the tolerance diagram. Tolerance diagram is a diagram that clears the cut-off frequencies and the magnitude of the passband frequencies. So we have two coordinates, which is the vertical h e to j omega modulus square, which is referred to magnitude, and the horizontal, which is omega or frequency. Here we are for the as I mentioned before, that we have these criteria or these equations, okay? These three equations and limits. We will applicate the limits of frequencies upon the tolerance figure. Okay, we have two main regions: the stop band region, okay, which is a light for the beginning and the ending of the figure, and the passband band or passband region, which is a light on the center of the passband filter. Okay, for the cut frequency, for the first stop frequency, we have the sigma or delta equal to 0.01 for the omega S1, and omega S2 we have also 0.02. I have forgotten to applicate the value here, which is 0.02, as according to the value here, okay, to the value here according to the equation. Okay, for the omega S1 equal to 0.1 pi, 0.02 pi. Okay. Sorry, 0.01 pi for the omega S1. Also, we have the omega S2, which is a stop band for the frequencies that outer of the upper cut frequency, which is SW2, which is equal to 0.8 pi. Okay, we have here also for the baseband or passband region, we have two frequencies. The first is WP1 and the second is WP2. WP1 refers to the pass frequency number 1, which is lower frequency, and WP2, which is upper frequency. Here we are 0.3 pi for WP1 and 0.7 pi for WP2, which is have the value of 0.95 for the lower limit of magnitude and the 1 for upper limit of the bass band, which is exactly applied for the frequency axis from WP1 to WP2, which is, as I have mentioned before, 0.3 pi to 0.7 pi. Okay. Also, we can from this figure we can calculate delta W1 and delta W2. For the delta W1, we refer to the difference between WS1 and WP1, the first stop frequency and the first pass frequency, and the difference between them, it's called delta W1. Delta W2 also the difference between the higher pass, the higher stop frequency minus lower the higher pass frequency, WS2 minus WP1, as we have calculated as in these two equations. Delta W1 equal to 0.3 pi equal to minus 0.2 pi equal to 0.1 pi, and delta W2 equal to 0.8 pi minus 0.7 pi, which is ending to 0.1 pi, which is equal difference frequencies. Okay, this is for tolerance figure. So for the other procedure, we can pick up this value from the figure. The first is WP1 equal to 0.3 pi, WP2 equal to 0.7 pi, WS1 equal to 0.2 pi, and WS2 equal to 0.8 pi, which is referred to the lower and upper stop frequencies, and upper and lower for the pass frequencies. Okay, for the second or for the other specifications. Okay, the second step is to locate the minimum stop attenuation, which is already given in question, about 75.3 dB. Okay, now referring to table 5 and select this value of nearest high value for the attenuation. If it is already exists, okay, no problem. Or if we have a different value which is not applied for the table, we can to approximate the value of attenuation to the near highest value. Okay. So from the table we can specify the type of window, which is Blackman, which is applied to the 75.3 dB attenuation. The third step is how to pick up the delta W as we made before. dW equal to dW1 delta W1 equal to delta W2, and which is 0.1 pi. For the how can we get the M, which is transition bandwidth? How can we select the M value, which is refer to the how can I shift the signal figure to the right by which value? Okay, this is M. From table 5, transition bandwidth column, from this column we can get dW equal to 5.56 pi over M. So as well as M will equal to 5.56 pi divided by 0.1 pi, and in the result we can get 55.6 for the value for M, okay, which is also approximate to 56, which represents the next highest value in the column. Okay, so the N value and capital value, which we will use in the equations of HD of N. To calculate HD of N, we need the N value, which is 2M plus 1 equal to 2 multiplied by 56 plus 1 equal to 113. Okay, so also we must get the cut frequency number 1, which is 0.25 from the tolerance figure, and cut frequency number 2, which is higher, okay, which is 0.75 pi. So we can calculate H of N as according to this figure. H of N equal to HD of N multiplied by window of N. Okay, already we have to calculate HD of N and window of N. So what's the formula that calculate these values? We are referred to this equation. The first is HD of N, which equal two value if N equal to 0 or N is not equal to 0. Okay, these are the formula, as formulas for the two cases. And Wn, we can use this formula to calculate W of N. We select three nominal values for N, which is 0, 1, 3, and put these value in using these formulas to calculate HD of N and W of N, and in the ending H of N, as you see in the figure. So to make a signal casual, the signal is shifted to right by M equal to 56, as we have calculated before, and the design was finished. Thank you.